I'll talk about a couple of projects really, and that were done by Akash and Ayaka in the last couple of years that sort of are trying to bring us closer to software-defined wireless networking or wireless software-defined networking or defined wireless software networking. People are sort of playing with these names and changing orders. But the basic idea is to sort of look at the role of software-defined networking in wireless systems, right? And so let me first try to sort of motivate from our perspective where the role of SDN in wireless really is. So, literally, the idea is that we have all these wireless systems that we are sort of trying to coordinate. And when I say that, I don't mean necessarily unlicensed systems. I'm also talking about wireless systems in general, and then especially in the recent sort of FCC attempts to create a little bit more open spectrum sharing agreements and to sort of come up with a way of better utilization for the available spectrum. And again, the assumption here is that we have multiple players in this game where Verizon's and AT&T's are somehow going to come up and sort of say, okay, we're going to share the spectrum, we have to coordinate. We are trying to limit what we are telling about our systems. I mean, everybody's sensitive, it's a business logic, right? So you don't really want to expose too much about yourself, yet you still need to cooperate because, you know, we are sharing the same spectrum. So, assumption is that there is some interaction between managed wireless networks, and we have to facilitate various ways of doing it, right? So that's the basic assumption. And so to illustrate that, let's assume that we have two networks, presumably they're using the same spectrum, right? So they have to somehow exchange this information. And of course, they want to limit what they're doing, and can we come up with the ways of doing that that are transparent and sort of self-coordinating, if you want to say. And again, you sort of don't necessarily have to even disclose what type of systems you have. You just have to say the basic stuff that is necessary for coordination, right? And again, we have some ideas as how this can be done in some simple cases. It actually gets much more complicated. Stuff that I'm not even going to talk about here is the semantics and the ontological representation of wireless systems. To give an example, frequency, right? When we say frequency, it means different things to different people. If you try to do ontological search on frequency, you will, for instance, get a CPU frequency as an answer. Right? That has nothing to do with wireless systems. And then, of course, assumption is that there are some policies involved, and we want to sort of be able to share these policies. So this is the ecosystem in which we are playing. I'm not going to talk about particular wireless systems. We did most of the stuff on Wi-Fi. We're now moving strongly towards LTE and WiMAX to sort of look at the coordination mechanisms, but rather talk about SDN aspects of the whole problem, right? So, following what the WIRED's SDN community is talking about, right? There's this notion of network OS that we want to extend with the wireless abstractions, right? And when you look at that, the data plane part is literally the same for both wired and wireless networks, right? Or similar. So most of the applications, you know, you say wireless access control, the same thing exists in the wired networks, which is access control, right? If you plug in the wire into a wall jack, somebody has to say, yeah, you're okay. Mobility is a little bit different, but you know, arguably I can go from home to work, unplug my laptop at home, plug it back at work, so there is mobility even in the wired case. And then of course we have a QoS, which is somewhat more difficult in wireless systems, but still these are, in our view, data plane applications. Right? What is really the focus of this talk is on the control plane side. And the idea here is that we want to use these network abstractions and extensions in wireless to sort of implement these control applications. And arguably, industry guys would say, well, are you sure this is control? Is this really more management than control? I mean, nevertheless, it belongs to a broad range of control applications. And I'll illustrate that with a couple of examples. So, what is the idea? The idea is that we somewhere in the system have multiple wireless controllers, in this particular case, 2 of them. We want to create a shared state, right? And again, this is control plane. In other words, data plane exists, and all these base stations are connected to the outside world, the packets are flowing in and out, clients are happily sending. We are literally talking about the control plane that needs to have a shared state. So this is sort of the notion of distributed control. That is already quite different from what wired guys are talking about. Most of them and most of the SDN deployments these days are in data centers, where you have a massive centralized SDN controller controlling all the switches in the data center. Things get much more difficult when you have a distributed controller, which is in this particular case 2 controllers that need to share the state. Of course, community is working really a lot on trying to do this same thing for wired deployments, but it gets a little bit tricky. Now, in case of wireless, we are sort of thinking that we don't have a single monolithic controller, right? I mean, there are all sorts of control functions that are completely different. Authentication has nothing to do with handles, right? So there is really no reason for us to create this massive monolithic centralized control. Again, there are some assumptions that we made on and I'm not sure, it does work. That we made sort of, that these controllers are going to use message passing, and this is, strictly speaking, influenced by OpenFlow, right? Because that's what it does. It generates these messages. And then, assumption is that multiple controllers are going to process each event. In which case, of course, we have to decide how is the control action going to be pushed onto the network, and for instance, which base station, is Verizon's base station really going to trust AT&T's control? That is something that I guess we don't really want to get involved in. But the assumption is that we have a wireless control stack implemented as interaction between controllers, right? That's the basic premise. Now, another thing that is obviously critical, and this actually has to do with the wireless nature and complexity of the wireless control plane, is the fact that we have certain actions which really have to be very close to the base station. Typical examples are radio resource management, right? I mean, we have a very strict latency requirements for most of the wireless systems, which of course means that you cannot have a radio resource management controller in San Francisco for a base station that's in New York, regardless of how fast your network is. I mean, the latency of 50 milliseconds is unacceptable for control plane. Which of course then implies that we have this ultimately heterogeneous hierarchical control plane, right? And assumption is that higher tier events are more global and less frequent. Typical example is maybe, let's say, I don't want to say handoff because that's not necessarily it could be actually a fast event, but say access control, right? I mean, that's an event that most network will go through once or twice when you access the network for the first time. Later on, they will translate that original verification of who you are into some sort of a token that you will carry with you and speed up the process.
I have a stupid question. What are the data rates that we're talking about, the information rates that we're talking about, so these sorts of collective things happening in that?
So that's actually, of course it depends on the number of base stations, right? If you're talking about picocells and a lot of them, then each of these tiers actually blows up, right? And you're talking about, depending on the system, right? In case of Wi-Fi, maybe on the order of, 40,000 access points on the local LAN is doable, which means on this layer, right? on this layer, maybe you can do one extra zero on top of it, right? But if you try to look at the country-wide, I mean, you can't do a country with a single tier controller, even for authentication, right? So it's huge, eventually. Now, an example, I mean, I guess this is the easiest example to sort of think about. Handoff is a fairly fast event, so let's say that happens in tier 1. We already know how to do distributed handoff controllers, so that is somewhat a standard problem. But then authentication and interference management can be on the layer, on the tier 2, right? And again, remember, the whole idea is that we want to sort of have all these base stations emit events that are control events in nature, and then the control layer to pick it up based on computing capabilities and available resources in all of these controllers, regardless of layer at which they are happening. Similarly, we really want to push the messages. If they don't belong to this layer, we want to push them out. So we literally have this east-west, north-south paradigm for control flows that need to be implemented. Now, I'm slowly running out of time, so I'll skip a lot of results, and we can, if anybody wants details, we can talk about it. So let me sort of outline what's missing in the SDN as it is today. And this is primarily on OpenFlow, right? This is not necessarily, I mean, there are some other mechanisms that people are using in calling software-defined networking. We are strictly focusing on OpenFlow mainly because that's the stuff we have. So there are solutions that are, scalable and mainly in data centers, and they are fairly reliable, meaning that the control plane is behaving reasonably well. But most of them are not readily available. So, if you look at some solutions, for instance, Aruba Enterprise Controller, one can argue that that's an SDN-based controller, scales well to the large number of Wi-Fi access points, but there is not much you can do with it. I mean, it's not an open source. Actually, it's really interesting. If you have a floor, and our favorite example is Goldman Sachs and JP Morgan, right? One is on the 3rd floor, the other one is on the 4th floor. Both have Aruba controllers. They can't coordinate between themselves because of the logical separation of the wireless deployment, right? And they are capable of doing it. It's just that there is no mechanism for them to actually do it. And they will cause massive interference with each other, right? So, again, they're still trying to do it, but it's not there yet. Another big problem with the existing SDN deployments is the fact that it's really, assumption is that all the controllers and all the control functions are unified, which means that you cannot have hierarchical distributed, non-homogeneous deployment. And then, of course, and this is, as you can see, there is a question mark here. There is now a big push to create what's called the SDX, or software-defined networking exchanges, where they realize that in intra-domain routing, you have the same problem, right? If you have multiple islands of wired networking, or multiple data centers, and you need to connect them, you need to create a point where these states of networks will be exchanged. And of course, people don't agree on what's the state and how to exchange it, right? So, these are the requirements that we came up with. I really Ayaka implemented this in the floodlight, and I'm not gonna, there are a lot of details as to how this is actually done with the introduction of event types and event processing and all that stuff. I just really want to sort of point out that traditional, which is this white section here, floodlight controller is extended with the green stuff that is really focused on adding these capabilities that we consider interesting. And again, it's all about being able to inject wireless events, control events, into the software-defined networking plane, use traditional software-defined networking mechanisms to distribute control, which allows us to sort of multiply control messages to different controllers, pass them north to the second tier in the north, or even go east-west between the multiple controllers of the same type. And so, just to look at it, these are sort of typical examples. If you have a client that is sort of injecting messages that are now going through the multiple tiers, you can actually see that they have a reasonable, in the local area network at least, reasonable delay. And you know, again, looking at all different types of messages, this is the divert message, right? And the split message where we are sending same message to multiple controllers, it sort of shows up that the actual stack could be implemented as long as, of course, these delays are acceptable. Again, for instance, for radio resource management, if your decision is delayed by 1.2 milliseconds, you know, it's too late, right? I mean, most of the radio resource management algorithms are way below this number, which suggests that you can't use these types of controllers for radio resource management. And again, that is an ongoing discussion as to where then and how can we come up with control mechanisms that are still exposed to the users, right, or in this case operators, and achieve the appropriate bounded delay. This is the last result in sort of showing the notion of the tiering. As you can see, the assumption here is that, you know, the higher you go in the tiering, the less variability in processing you have, right? And again, this is again very specific to open flow type of SDN. Now, practically where we are at right now, and I have 3 minutes left, which is perfect. We have two types of, so most of this was done for Wi-Fi, first for wired systems and then for Wi-Fi systems. What we're trying to do now is to move and encompass others, including WiMAX and LTE. And again, the main reason why we can do this is because we created an API that exposes all the controllable parameters in the base station. And, you know, doesn't necessarily mean we understand all of them, honestly, even though we are wireless guys, right? I mean, there is about 700 parameters that each of these two types of base stations exposes. But nevertheless, the assumption is that somebody will have an idea why they want to change the HRQ delay or whatever parameters of an HRQ. And so we exposed all these parameters to the same API, and they're now turning them into the software-defined networking events as the base station reports what's happening, right? And then, so if you look at how this really looks like, and most of you already saw these figures, so we have what we call the RF Aggregate Manager, which is really talking on the control plane to the base station. Data path is handled with traditional software-defined networking. And then on this end over here, we really connect to our SDN control plane. Similarly, and this is actually an ongoing process, we're still struggling with this. In case of LTE, we are replacing all the control software that's running in the controller outside of the base station with the, similarly for data path with the open switch, and then creating yet another interface for control management. The difference here, as you can see, is that we are assuming that there is some control function sitting very, very close to the base station. And the idea, of course, is that these are going to be used for radio resource management or any function that needs fast feedback. All of this is actually now available as part of the Genie deployment, right? So we have a number of base stations of both types, and even more wireless access point if you count Orbit into that, that are connected to this massive SDN data path complex. Each of the sites has, at the moment, SDN-based handoff controller, which again is literally nothing else but a floodlight which is talking to the data path implementation. We, you know, people who want to play with the handoffs have to come up with their own algorithms. We just facilitate that, right? And then the light green stuff is really where we are sort of more enablers than really implementing anything. Nobody knows how this will actually look like. The point is that we have control plane, which is blue, talking to this amorphous software, piece of software or server that can implement all sorts of things, right? And research is, yes?
The access link measurements, are they also scheduled as in the control?
Yes. So in other words, it's a little bit complicated. If you look at this layer here, it allows you to register for any kinds of measurements that the base station can generate. So in other words, by default, base station doesn't send anything, right? In a sense that we don't want to generate measurements that nobody's interested in. But through this, you can sort of say, oh, I want to get, I don't know, RSSI measurements for this client every millisecond, right? And of course, if the base station can support that, it will start suddenly sending that all the way up, or you know, whatever other measurements are available. And again, here it's not, you know, ideally we will want to define these measurements ourselves, but you know, these are commercial base stations, so we have to live with whatever is available. So we try to expose all of those.
Are you close to any like real world deployments?
These are all real world deployments. So there is a base station on Bush campus.
I mean, what is it? I mean, it's on Bush campus?
Yeah, there is one on the roof of core building. We have one. We actually have two on Route 1. One is the LTE base station. The other one is the WiMAX base station.
But do you like? Is there like a real problem where you solve things? Like in core building on 5th floor, you have 3 providers. One is WINLAB, the other one is LAN, the third one is PCE.
So yes, if
you never get Wi-Fi access.
I know, yes. So.
So
that would actually be interesting if you could coordinate the 3, and you know, but it's Rutgers, so it's even worse than AT&T versus Verizon. I mean, I'm sure we can harmonize AT&T Verizon easier than RU Wireless and WINLAB, right? Or LAN. Actually, LAN we could probably do something with, but I don't know. So anyway, that's it. I'm over. I'm 3 minutes over. I was trying not to be, but.